on decay. Example 3. Strontium-90 is a waste product from nuclear reactors as a consequence of a fallout from atmospheric nuclear tests. We all have a measurable amount of strontium-90 in our bones. The half of strontium-90 is 20 years, meaning that after 20 years, the given amount of the substance will be decayed to half of the original amount. Find the exponential decay for the strontium-90. So here, first of all, we want to find a formula how we can calculate the strontium. But what is saying here is saying the half of strontium in 90 is 28 years. So first let's try in A. Let me take a pen here. In the A here, let's take A, let's make a formula, is equal to the A0 times E in exponent kt. So now it means in 28 years, so A0, let's say, is A0, and what it says, the half of strontium in 90 is in 20 years. So it means A0 divided by 2. In 28 years, this strontium is going to be in the half. So the amount here is A0. And is E in exponent k. Instead of the t, we are plugging in 28 years. And now everything here we divide in by A0. And if we divide everything by A0, it is going to be 1.5, which means it's 0.5. Going to be equal with the E in exponent k times 28. Now, here we take in ln both sides. When we take in ln, it's going to be ln 0.5. In this side is ln E in exponent 28k. Now, in this here, let me take this calculator. We take ln 0.5. So 0.5 ln is negative 0.69. Let me take a negative 0.69. And in the other side here, we are using the properties of the lux. The power property, this 28k is going to be here in the front. 28k. And ln E. But ln E, we already know this is going to be equal with 1. 1 times 28k, 28k. So in fact, this is going to be equal with 0, negative 0.69 is equal with 28k. We divide everything by 28, and finally, k is going to be equal with, now we are going to divide both sides by 28. So what is k? Now let's divide this by 28. And k is negative 0.0247, but let's approximate this with a negative 0.025. So we are approximating in thousandths. So this is k. Now b, let me write b with a different color. B says, suppose that a nuclear accident occurs and releases 60 grams of strontium-90 into the atmosphere. How long will it take for strontium to decay to the 10 grams? So it means A, instead of the formula here, what we have, A times, now we use this formula. A is equal to the A0 times E, and instead of the constant K here, we have minus the 0.025 times T. And now we want to know how long it's going to take for strontium to decay to 10 grams. And the now here is a 60 gram. And instead of the A here, we plug in here 10 gram. And A0 is a 60 gram. We want to know this how long it's going to take to go to 10 gram from 60 gram. And E is a minus 0.025 T. We want to calculate the time T. So what we are doing here, first of all, we are dividing everything by 60. When dividing this side by 60, 60 is going to disappear, and this side 10 divided by 60 is 1 over 6. So 1 over 6 is going to be equal with the e in a minus 0.25 t. So this is 25t. And now we take an ln both sides. So ln 1 point, here is ln 1 over 6 is equal with the ln e in exponent minus 0.25 t. And now we're going to see here in calculator what we can do it. So we take in a calculator here now ln 1.6. So let me take this out. 1 divided by 6 is equal, and I'm taking a ln, which is negative 1.79. We have this is a, let me write here with a different color. Negative 1.79 is in this side, and the other side of this ln is going in the front. What is going to be here? Minus 0.25, 0.025. In fact, it's because two zeros are here. Let me write here are two zeros. Okay, and here is two zeros. 0.025. So just let me erase this here by the 0.025, and is t. Everything we divide by negative 0.025, and this side by negative 0.025, and t is going to be equal. So now this value here I'm divided by negative 0.25. Let me make a negative. And this is a 71. It means it takes about 71 years.